Hello everyone, welcome to the Learning Cubicle. In the last class, we have learnt about motion graphs and one of the motion graphs, that is displacement time graph. In this class, we will learn about another motion graph, which is velocity time graph. Now, as I have already told you in the previous class, in all these graphs, time is always taken on the x-axis and the other quantity is taken on the y-axis. So here in this case, the other quantity is velocity. So velocity goes on to the y-axis. Now here, coming to the slope, what information can we get from this? We can actually get a lot of information from this velocity time graph. That is, from the slope, that is difference of coordinates on y-axis divided by the difference of coordinates on x-axis, that is velocity by time. We discussed that the ratio of velocity and time will give you acceleration. So from the slope of this graph, we can get the acceleration of a body, right? Apart from that, we can also get displacement from this graph. So by calculating the area under the graph, whichever graph, area under the graph, we can actually get the displacement of the body, right? Now, coming to different situations, what situations we have discussed in case of displacement time graph, the same will be discussed even here also, right? So you can see here, there is a body whose velocity after 1 second is 15 meters per second. After 2, it's the same. After 3, it's the same. After 4, 5, 6, also it is the same. That means with the change in time, the velocity of the body is not changing. That means the velocity is moving, but it is not increasing or decreasing its velocity. So we can say that the body is moving with uniform velocity. So when the graph is a straight line parallel to the x-axis, in case of velocity time graph, the body is moving with uniform velocity. Now let's move to the next one. Now look at this here. After 2 seconds, the body is having a velocity of 4 meters per second. After 4 seconds, it is 8 meters per second. After 6, it is 12. After 8, it is 16. After 10, it is 20. After 12, it is 24. That means the velocity of the body is changing with time. That means the velocity of the body is no longer uniform. So we can say that it is non-uniform. The velocity of the body is non-uniform. So here the body is moving with non-uniform velocity. At the same time, if you observe carefully, for every 2 seconds increase in time, there is a change in velocity of 4 meters per second. So for every 2 seconds, there is a change in velocity of 4 meters per second, which is 2 meters per second square is its acceleration. So the acceleration of the body is maintained the same throughout. So the body is moving with a uniform acceleration of 2 meters per second square. So when the graph is a straight line passing through the origin, the body is moving with a non-uniform velocity, but it is moving with a uniform acceleration, right? Now let's move to the next graph. Now we came across the same thing even in the previous case, the displacement time graph. Even here, if you can see here, after 2 seconds, the velocity is approximately 1 meter per second. After 4, it is somewhere around 2 meters per second. After 6, it is somewhere around 5 meters per second. So it is not having equal changes in velocity, equal change in velocity. So the body's velocity is non-uniform over here. So it is moving with non-uniform velocity, but the acceleration is also non-uniform over here. It's not happening like in the previous case when the graph is a straight line passing through the origin, the acceleration was uniform, but here the acceleration is non-uniform. So when the graph is a curve passing through the origin, the body is moving with non-uniform velocity, and also the acceleration of the body is also non-uniform. right? Now let's move to the next graph. Now you'll be surprised that there's no curve over here. But if you observe carefully over here, the blue line that you were seeing is over here. It's over here, right? So after 3 seconds, the body's velocity is 0. After 6, also it is 0. After 9, 12, 15, the velocity of the body is 0. So even when the time is changing, the velocity of the body is still at 0 meters per second, which means the body is not at all moving and the body is at rest. So when the graph consists of all its points on the x-axis, in case of velocity time graph, we can say that the body is at rest. Thank you.